These are the solutions to the Leaving Cert 2023 Ordinary Level Maths Paper 1. Section A, question 1a. A house is valued at 240,000 at the start of 2019. By the end of 2020, the price of the house had increased by 8%, and by the start of 21, the price had increased by a further 9% based on the 2020 price. Work out the price of the house at the start of 2020 and the price at the start of 2021. So there's two parts to this question basically. So first of all, let's work out the price of the house at the start of 2020. So that's basically 8% added on to the original price of 240,000. So 240 plus our 8%. So to get our percent, we divide by 100 and multiply by the 8. So 240, 1, 2, 3 zeros, divided by 100, and then multiply by our 8%, which is giving us 19,200. We then add that on because that's the increase to the 240,000, and that is going to give us the price of our house at the at the start of 2020, which is going to be 259,200 euro. We then need to do out the price of the house at the start of 2021. So same procedure here, except this time we're taking the 259,200 euro. We're going to add on the 9% for the increase that year. So divide by 100 multiplied by 9%, which is an increase of 23,328 euro. We're going to add on the price at the start of 2020, which is going to be the 259,200 euro, which is going to give us a price at the start of 2021 of 282,528 euro. So to get your percentage, divide by 100 and multiply by the 8 or multiply by the 9. Another house has a value of 460. 1 year later, the value of this house had gone up to 472,000. Work out the percentage increase in the value of the house over the year. Give your answer to one decimal. So this is basically percentage difference, percentage error, and our formula here will be the difference of the prices over the original price, and then we multiply that by 100 over 1 to turn that into our percentage. So the differences in the price is going to be the 472,000 minus the value of the house, which was 460,000. We take them away from each other and we divide it by the original. The original is the starting value, which is the 460,000. Taking them away, that's going to give us 12,000 euro divided by the 460,000 multiplied by 100 over 1, and that's giving us 2.608%. Question wanted to one decimal point, so 2.6%. So our formula here for percentage change is difference over original. Moving down now to part C. A third house valued at 265,000. Over the following 4 years, the value of the house increased by %, each year compared to the previous year. After 4 years, the price of the house was valued at 370,000. So they've given us the formula here for finding the final value or the future value. That's our compound interest formula from our log tables, but they've given it to us here in the question. And we basically just have to fill in everything. So they're telling us most of the information here. So we're subbing 370,000 in for F, 265,000 for P, and we're subbing in 4 for T. What you're trying to find in this question is the value of R, the interest rate. In the log tables, that's I. So in the log tables, it's F equals P bracket 1 plus I to the power of T. They've just changed that around ever so slightly. So filling it in, we have our 370,000 for final or future. We have P present or principal at 265,000, bracket 1 plus the interest rate, which is R, so we're going to call it R over 100, because to turn a percentage into a decimal, we'd have to divide by 100. Multiply to the power of T, which is to the power of 4. First thing I'm going to do here is I'm going to divide both sides by the 265 in order to get rid of it from the right hand side. So dividing both sides by 265, which will give us 74 over 53 when we type it into our calculator and simplify it. You can turn it to decimal if you want, is equal to 1 plus or over 100 to the power of 4. Next step then will be to deal with the power of 4 here. We need to get rid of this. Now there's a couple of ways you can get rid of the 4. You can use the 4th root, so put the little 4 on it on your calculator. Just make sure you do that to both sides. Or we can multiply both sides to the power of 1/4, because what I'm going to do here is I'm going to multiply 4 by 1/4, and when you multiply 4 by 1/4 you get 1. So that's what I'm going to do to both sides. So I'm going to multiply the power here by 1/4, and if I do that to the right, I need to do that to the left. So I'm putting this to the power of 1/4. So when I multiply the left to the power of 1/4 in my calculator, I get 1.087 equals the 4 multiplied by the quarter would become 1. So that becomes 1 plus or over 100 to the power of 1. Now anything to the power of 1 is just itself. So that's just going to give me 1.087 equals 1 plus or over 100. Next thing I want to do is subtract 1 from both sides to get rid of that 1. So that's going to be 1.087 subtract 1 is equal to or over 100. Taking them away will get you 0.087 equals or over 100. And I have a fraction equals to a decimal, so multiply across by 100 or put it over 1 and cross multiply. So or multiplied by 1 will get you or, and 0.087 multiplied by 100 will get 8.7%. And the question wanted it to one decimal place, so that is fine. So that's question 1 finished. Question 2, complex numbers. A, the complex number Z1 is shown on the Argand diagram below. Part 1, plot and label Z1 conjugate, the complex conjugate of Z1 on the diagram above. So the conjugate basically just means you change the sign in front of the I. So Z1, let's just do it out here. The complex number Z1 from the diagram is 3 minus 3i. So the conjugate of that is going to be changed the sign in front of the I to a plus. So 3 plus 3i. So I plot that, 3 plus 3i, which would go here. It says label it, so just make sure you label it Z1 conjugate. So see here it says label it, and they put that in bold. Part 2, plot and label Z2 and Z3 on the diagram above. So let's do Z2 first of all. So that's across 5 up 1i, so that's Z2. And then the Z3, which is across the 6 and down to minus 2i, which would be here. So that's Z3. Again, it says here, label them. Write 4 times Z2 minus 5 times Z3 in the form a plus bi. So we're on part 3 here now. So the 4 is stuck to the Z2, so that means multiply. So it's 4 times Z2, which is 5 plus I. Subtract 5 times Z3. Z3 is 6 minus 2i. Then multiply in my brackets. 4 by 5 is getting me 20. 4 by I, 4i. Multiplying in the minus 5 by the 6 will get me minus 30. And minus by minus 2i will become plus 10i. I then group them. So I have a plus 4i and a plus 10i, which will get me 14i. And then I have a 20, subtract a 30, which is giving me minus 10. So minus 10 plus 14i, and that is in the form a plus bi. Looking at IV, work out the value of the conjugate, the modulus of Z3. So these little brackets here, these square brackets, are meaning modulus, and we'll write down the formula now to that in a second. First thing we need to do is write down what is the value of the complex number Z3. So we're looking for the modulus of Z3. Z3 is given to us there on page 6 of the booklet, so 6 minus 2i. The formula for modulus is given as the square root of a squared plus b squared. Now the a is the real part and the b is the part in front of the I, the imaginary part. So my modulus of Z3 is going to be the square root of 6 squared plus minus 2 squared. Just make sure you put them in brackets for your calculator work if you're doing it on calculator. So that's going to give us the square root of 6 sixths, which is 36. Minus 2 by minus 2 is plus 4. So it's Z3 modulus is equal to the square root of 40. Put that into your calculator and you'll get 2 root 10. The question, if you read it again there, it says it wants it in third form. So that's its simplest form in square root that doesn't want it as a decimal. It can't be simplified any further. So 2 root 10 is our answer here. Question 2b. The complex numbers Z4, 5, 6 and 7 are shown on the Argand diagram below. The diagram is not to scale. So in other words, don't measure off it. Tick one of the boxes to indicate which of Z4, 5, 6, 7 has the largest modulus. Number with the largest modulus. Tick one only. So I'm going to tick Z5 here. The question wants a reason for it. And the reason for it is because it is the furthest away from the origin. So if you were to kind of look at these here, draw a line from the center to each one of them. By eye, it looks as though Z5 is the furthest from the origin. So that's my answer here. So reason Z5 is furthest from the origin. And that is question 2 complete. Question 3 is algebra. Question 3a, solve the following equation in x, where x is an element of the real numbers. So writing this down, we have 3 bracket 2x plus 4, take 5 equals 3. I'm just going to keep my equal sign coming down the page so we don't move it, or we don't stray too far from here. So multiplying into 3 by 2x is 6x, 3 4s are 12, and minus 5 equals 3. Don't multiply the 3 by the 5 because it's not in a bracket. Grouping like terms, 12 take away 5 is going to get me 7. So I have 6x plus 7 equals to 3. Taking 7 away from both sides is going to leave us with 6x equals 3 minus 7. So that's 6x is equal to minus 4. Dividing both sides by 6 is leaving me with x is equal to minus 4 over 6. Simplifying that down will become minus 2 over 3 because 2 divides into 4 twice, 2 divides into 6 3 times. Looking now at part B, inequalities. Graph each of the following inequalities in the number line. Note that x comes from a different set of numbers in each case. Okay, so x is less than or equal to 2.8, where x is or. So x is an element of the real numbers. Real numbers, don't forget, are every single type of number that you can think of except for complex numbers, the imaginary numbers. So we're going to 2.8 and it's less than or equal to 2.8. So let me just zoom in here a little bit. So we're drawing a circle at roughly 2.8. I'm not coloring in the circle, or sorry, I am coloring in the circle because it includes the 2.8. And then I'm drawing a solid line less than 2.8 to account for all of these infinite numbers that are also included, which are less than 2.8. Part 2, x is less than or equal to 2.8, where x is a integer. Z is our integer numbers. Integer numbers are positive and negative whole numbers. So the first one there would be 2. I don't include 2.8 because that's not a whole number. I don't include 3 because x has to be less than or equal to the 2.8. So the first whole number less than 2.8 is 2. Then I include the 1, the 0, and so on and so on. Integers include negative numbers and positive numbers. In the final part though, it wants x less than 2.8 where x is an element of n. N are your natural numbers. First natural number is 1 and it goes to infinity. So 1, 2, 3, 4, 5, 6, so on, so on, so on. So less than 2.8, my first one would be 2, 1, and that's it. I stop here because 0 is not natural. Okay, so scrolling down now to part C. It's a simultaneous equation. Just be careful here before you start your simultaneous equation. I would just move the 1 over the equal sign here, that I have the x's over x's, y's over y's, numbers over numbers. So that's going to be my simultaneous equation, x minus y equals negative 1, 2x plus 4y equals positive 19. Now, I personally do these out twice rather than subbing in. Subbing in is fine, but I'm just going to do them out twice. So in the first one, I'm going to cancel the x's. So I'm going to multiply the top line by a positive 2, then I'll multiply across by the minus. So I'm getting top line times by 2, which is that, and then the 2x plus 4y equals 19. I then change the signs on the top or bottom line. I'm just going to change the signs on the bottom here. So minus, minus, minus. 2x minus 2x is 0x, so they'll cancel out. Minus 2y minus 4y minus 6y equals minus 21. Dividing now across by the minus 6 will leave me with y is equal to minus divided by minus, which is positive, 21 over 6. Simplifying that, divide top and bottom by 3, we'll get 7 over 2. So that's my value for y. Now I'm coming over and finding the value of x. So I need to multiply the top line by 4 to cancel the y's. So top line by 4, 4x minus 4y minus 4. 2x plus 4y equals positive 19, stays as is. Don't change the signs because the minus 4y and the plus 4y are already different. They'll cancel out. So 4x plus 2x is 6x, and minus 4, forgot my equal sign there, plus 19 is going to get me positive 15. Dividing both sides then by 6 is leaving me with x is equal to 15 over 6, which can simplify by dividing top and bottom by 3, which is 5 over 2. So there's my value for x. And that is question 3 finished. Question 4a is functions. The graph of the function g is shown on the coordinate diagram below. Use the graph to answer part A1 to AIV. So using the graph. So they'll give you a little bit of leeway here in the marking scheme if you're a little bit off, because you're just estimating from the graph. So part 1, estimate the value of g of 1.5. So g of 1.5, so that's basically g of x. So 1.5 would be, let me find it. So this is 1.5. I draw my line up, come across to my y-axis, which is giving me a value of 2. So g of 1.5 is 2. Estimate the value of x, which has g of x equal to minus 6. So let me just clear off my graph here. So I'm coming to minus 6 as my solution. So that's on my y-axis. I'm not going this way because look, it's never going to cross my curve. So I'm actually going down into the negatives here. So it's bringing me all the way back to here. Now, where does that come when I bring it up to my graph? This here is minus 2.5. So it's somewhere between minus 2.5 up to minus 3. So look at roughly 2.75 minus 2.8, something like that. So there's a little buffer zone built into it there as a margin of error. And part 3, tick one box to show how many real roots the function g of x has in this domain. So the roots are basically where it crosses the x-axis. Now my graph, crosses the x-axis just once. Here, it doesn't cross the x-axis. So they're what's called imaginary roots. So it has only the one real root here. And the question asks for a reason, and my reason would be it only crosses the x-axis once. Okay, so that's part A done. Actually, we have part IV as well here, which wants us to read it from the graph as well. So from the graph, estimate the coordinates of the local maximum point and the local minimum point. So let's start with the local maximum. The maximum turning point is basically the highest point on the graph where it turns. So my maximum point would be here, where if I was to draw a line, it basically has a slope of 0. So that would be my maximum turning point. Now, where is that? That's roughly maybe minus 1.6 down to minus 1. Would that work? It looks about right to me. Let's go with that anyway. Minus 1.6 down to minus 1. And then the local minimum is where the turning point's at its lowest, which would be around here. Again, where the slope would be 0 would be your turning point, and it's the minimum. And that is going to be, well, if this is a half, it looks like it's about a quarter of the way. So a positive 0.25, and it looks like it's coming just below the minus 3. So maybe minus 3.1 or minus 3.2. So 0.25 down to minus 3.1. Part B. A different function, h of x, has the following equation. Find h dash of x. So this is differentiation, the derivative of h of x. So we multiply the power by the number in front of the x. So there's a 1 in front of that x cubed. So 3x reduced the power by 1, so 3x squared. Coming to the next part here, multiply the power again by the number in front of the x. So 2 by 2 is 4. Reduce the power, so 4x to the power of 1. The next one, minus x. This is to the power of 1. There's a 1 in front of the x. So power by the number gets me, that should be a negative 1. Reduce the power by 1, so x to the 0. And when you differentiate a constant, it just drops off. We should hopefully know that x to the power of 0 is just going to be 1. So 3x squared plus 4x minus 1 is your derivative. So that's your h dash of x. And part 2, find the equation of the tangent to h of x at the point 2, 6. So a tangent is a line that touches the curve just once. So don't forget, differentiation basically means slope. So what we're looking at here is the slope when x is equal to 2. So we're looking for slope when x is equal to 2. I have a formula for my slope. It's h of x, dash of x, which is from part 1 up above. So all I'm going to do here is I'm going to sub in my value for x. So 3 bracket something squared, 4 bracket minus 1. I'm putting in my 2 given in the question here. The coordinate we're looking at is 2, 6. So that's going to give me 4 by 3, which is 12, plus 8 minus 1, which is giving me a slope. I'm just going to use the letter m here for slope of 19. My equation of the line from my log tables, y minus y1 equals mx minus x1. Subbing in my point and so on. So I have y minus, let's just label my point here. It's x1, y1. So that's going to be y minus y1, which is 6, equal to my slope, which is 19, which we found, bracket x minus x1, and x1 is 2. Then I'm just going to multiply in that 19 into the bracket. So I'm getting y minus 6 equals positive 19x minus 38. And then I'm just going to move everything to one side. So I'm going to move the 6 and the minus 6 and the positive y to the right hand side. So that's getting me 19x minus y minus 38, and the 6 is now a positive 6. So 19x minus y minus 32 equals to 0. And that would be the answer to question 4. Question 5a, part 1. A company is repairing a railway line. As part of this work, it is laying new railway tracks. It costs €12,000 to lay 240 metres of track. Work out how much it would cost to lay 320 metres of track at the same rate. So a little bit of algebra here, really. So I have 240 metres of track is costing €12,000. So let's work out how much it costs, first of all, for 1 metre of track. So I'm dividing both sides by 240. So a little bit of algebra, really. Divide both sides by 240. So 1 metre is costing €50. The question wants me to get 320 metres of tracks. So I just need to multiply this by 320. So 50 multiplied by 320 is €16,000. So my answer there is going to be 16,000. Part 2. It would take 6 people 8 days to replace the tracks on a different part of the railway line. Work out how long it would take 4 people to replace these tracks, each working at the same speed. So again, let's set it up algebraically. So 6 people. What do? They take 8 days. So let's see what one person takes. So one person would take 8 times 6. So they have to do 6 times the amount of work if you're doing it on your own. So kind of think of it that way. 6 people take 8 days. One person is doing the work of 6 people. So that's 8 by 6. So one person is going to, unfortunately, take 48 days. Now I get some help. I have 3 extra people, so I now have 4 people. How long do they take? So they're going to share the workload. So the 48 days is going to be divided by the 4 people. So 4 people are going to take 12 days to lay the train track. Now, always do these questions with a little bit of common sense here. It's surely going to take 4 people longer than 6 people. So the 6 people did it in 8 days and the 4 people did it in 12 days. That kind of makes a little bit of sense. Many different ways you can look at that question. You can look at it using ratios as well. So whatever way works for you. Moving down now to part B, 1 and 2. B, 2 towns, A and B, are 120 kilometers apart. A train travels from A to B at an average speed of 180 kilometers per hour. Work out the time it takes the train to get from A to B. So hopefully we're writing down our distance, speed, and time triangle. The question is looking for time. So time, if we cover it, is going to be distance over speed. So the time taken is going to be the distance, which is 120 kilometers. I'm dividing that by my 180 kilometers per hour it takes to get there, the average speed. So that's coming out at a time of 2/3. So it's 2/3 of 1 hour, basically, is what it's telling me, because it's kilometers per hour. So 2/3 of 1 hour. To get 2/3 of 1 hour, we divide by 60 and multiply by 2. So 2/3 of 60 is what I'm looking for. 60 minutes in an hour. So divide by 3, you get 20, multiply by 2, which is 40 minutes. And actually, I'm just reading the question here again. It did say give your answer in hours as a fraction. So my answer actually is, we don't actually need this, but just if you ever do, that's how you do it. But my answer to this question is this part here, 2/3 of 1 hour. It didn't want us to put it into minutes. And part 2. On the way back from B to A, the train travels at an average speed of 220 kilometers per hour. Work out the average speed of the train for the entire journey while it is traveling from A to B and back again. Give your answer in kilometers per hour. And they've given us a little hint there. So before we can find the average speed, which the question wants here, if you look at it here, the question wants the average speed. The formula for speed, if we write it down here, is given as distance over time. Now, we know the total distance. It's 120 kilometers there and 120 kilometers back. So that's 240 kilometers. But we don't know the total time it took. We know the total time it took to get there. It's here, 2/3 of 1 hour, or 40 minutes. But we need to find out the total time it took to get back. So we need to figure that out first. And that's what the hint is saying. Hint, first find out the total time. So the time to return, so let's work this out. Time of return. So time is given as distance over speed. And the distance is 120 kilometers. That's from A to B. Now the speed, we're given in the question actually. You can see it here. It says that the train travels at an average speed of 220. So we're going to do 120 over the average speed of 220 kilometers per hour. Simplifying that down, we get 6 over 11. So 6/11 of 1 hour, basically, is what it's saying. Now the total time of the journey, so total journey time is going to be the 2/3 from B part 1, or 40 minutes, plus the 6/11 of 1 hour. If you type that into your calculator, you get 40 over 33 of 1 hour. So if you go 40 over 33 multiplied by 60, that is going to give you 1.21 hours. So the total journey took 1.21 hours. And if we come back up here to the top now, and my distance, total distance is 240 kilometers, over the journey time, which is 1.21 hours. So it's not 1 hour 21 minutes, it's 1.21 hours, which is giving me, when I divide it, 198 0.35 kilometers per hour. And the question wants it to the nearest kilometer per hour. So that's going to be 198 kilometers per hour. And that's question 5 finished. Question 6 is functions. Question 6a, g of x is the following function. Find the value of g bracket minus 5. So we're subbing basically minus 5 in for x. So g of x, let's just write it down first of all, is x squared plus 8x minus 6. I'm looking for g of minus 5. So everywhere you have an x, you're putting in minus 5. Just use brackets there for your calculator because it's a negative. Minus 5 by minus 5 is positive 25 minus 40 minus 6. So that's getting me a value of g of minus 5 equals to minus 21. Part 2, use calculus to find the value of x, which gives a minimum value of g of x. So your minimum value is when your derivative, or dy dx, is equal to 0. So that's your turning point, basically, your minimum turning point, which we looked at in a previous question. So that's just your little note there to have handy. So your g of x, your function, is x squared plus 8x minus 6. The derivative of it, differentiated, becomes 2x plus 8, drop the constant. Then your minimum turning point is when that g dash of x, or your dy dx, is equal to 0. So I'm going to let that equal to 0. I'm going to solve that then, just a little bit of algebra. So take 8 away from both sides. So I get 2x is equal to minus 8. Dividing both sides by 2 will get me x equals to minus 4. Now it wants us to find, I thought I was looking for the minimum turning point. It's not, it's just looking for the value of the x. And that's it, the x is minus 4. Moving down now to part B, expand and simplify the following. Just remember what a square means. A square means you multiply it by itself. So it's 2x minus 4 squared, which means multiplied by itself, and subtract the 6. Opening out the two brackets, it's first term by second bracket, second term by second bracket, and don't forget, I'm just going to change the color here to include the minus 6 each time. So minus 2x by 4, 2x becomes 4x squared. 2x by minus 4 minus 8x. Minus 4 then multiplied into the second bracket will give me minus 8x, and a minus by minus gives me a plus 16, and don't forget the minus 6. Tidying it up then, I have 4x squared. Minus 8x gives me minus 16x. And the plus 16 take away 6 is giving me positive 10. Down now to part C. Solve the following equation in x. Give your answer to 2 decimal places. Now, sometimes you can use your guide number, 2 brackets, but the key here is, the hint is to 2 decimal points. So that means you have to use your quadratic formula from your log tables. So your minus b formula is x is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Good practice, write down the values of your a, b, and c. My a is the number in front of the x squared, which is 9. The b is the number in front of the x, which is positive 6. And the c is the constant, which is minus 5. And then filling that into my quadratic formula. So x is equal to minus b minus 6 plus or minus the square root of 6 squared minus 4 times a, which is 9, times c, which is minus 5. All over 2 times a, 2 times 9. X is equal to minus 6 plus or minus, tidying up my square root, 6 sixes are 36, minus 4 by 9 by minus 5 gets me positive 180, all over 2 9s, which are 18. X is equal to minus 6 plus or minus the square root of 216 over 18. So, therefore, my 2 solutions for x are x is equal to minus 6 plus the square root of 216 over 18, and x is equal to minus 6 minus the square root of 216 over 18. So I have my 2 answers. I have the plus value and the negative value. Typing both those into my calculator, and just read the top of the question there again. It said to 2 decimal points. So I get 0.48 and I get minus 1.15. And that's question 6 finished. Section B, question 7a. When it rains on land, some of the rain soaks into the land and the rest runs off the land. The runoff curve number C is a number used when estimating the amount of rain that runs off a particular area of land. C is given by, where S is a measure of the maximum amount of rain that can soak into the soil. Part 1 wants us to find the value of C when S is 15. So we're basically subbing in 15 for S. So C is equal to 1000 divided by S, which we're subbing in 15, plus 10. So C is equal to 1000 divided by 25. So therefore C is equal to 40. Part 2, when S increases, does C increase or decrease? Justify your answer using the equation. So the answer here is that it's in fact going to decrease. And the reason for that is because think of it this way, when you divide by a denominator, so the denominator is the bottom of the fraction. So when you divide by a denominator that's bigger than the numerator, the answer is going to be smaller. So the bigger the value for your S, the bigger the denominator. And the bigger the denominator, the smaller your answer is if you turn it into a decimal. Now, the best way to see that is to try and see it. So just let's assume S is 5. So we have 5 plus 10. So that's 1000 divided by 15. Let's just see that out on a calculator, is giving us 66.6 as a decimal. Now, let's say we had, say, 500 as S. So let's go 500 plus 10. So that's going to be 1000 divided by 510, which is giving us an answer of 1.96. So what that's telling us is the value of my answer C is in fact decreasing the bigger the value I put in for S. So that's basically my justification. I'm just going to state, so because when dividing in general, the bigger the numerator, or sorry, the denominator, I should say, the bottom of the fraction, the smaller the answer. Okay, so because when I'm dividing, the bigger the denominator is, the smaller the answer will be. And I've just done it there through a couple of examples there. So part 3, rearrange the equation to write S in terms of C. So my equation again is C is equal to 1000 over S plus 10. I'm going to cross multiply, so put that over 1, cross multiply. So that's going to give me C times S plus 10 is equal to 1 times 1000. Just multiplying in that bracket now is going to give me CS plus 10C is equal to 1000. Again, the answer here, I want S is equal to everything else. So CS is equal to 1000. Move over that 10C, or take 10C from both sides. And my final step here will be divide across by C. So if I divide both sides by C here, I'm going to get S is equal to 1000 minus 10C all over C. And that's my answer. Rearrange the equation to write S in terms of C. Part IV. The values for C go from 30 to 100. Use your answers to A part 1 or otherwise to find the range of values for S. So let's just keep part 3 there. So coming from part 3, my answer for S is 1000 minus 10C over C. Now I'm going to basically do this out twice here. I'm going to sub in values for C to be 30 and 100. So S is equal to 1000 minus 10C over C. So in my first one, I'm going to let C equals 30. And in the second one, I'm going to let C is equal to 100. So that's going to give me S is equal to 1000 minus 10 times 30 divided by my C, which is 30. And in my second value, it's going to be S is equal to 1000 minus 10 times 100 over 100. Okay, so when I work that out on my calculator, I'm getting my first value of S to be 23.3, and S is equal to 0, in fact. So use your answers, or otherwise to find the range of values for S. So my values for S are ranging from 23.3 to 0. And if I put that down into the answers where it wants it, so S is going from 0 to 23.3 or 23 to 0, whichever way we want to write it, 23.3. Okay, so this question continues on the next page. So looking now at part B. So B part 1, write down the probability that it is raining at the start and the end of the day. That is, find the values of P0 and P24. So we're subbing in 0 for T, and we're also going to be subbing in 0 or 24 for P. So my first one here is going to be P of 0 is equal to 0.3 plus 0.02 times T. Again, 0 as T. So P of 0 is equal to 0.3 plus 0, which is 0.3. I'm now going to put in the end of the day. So that's the start of the day. The probability is 0.3. At the end of the day, it's going to be P of 24. So that's 0.3 plus 0.02 times 24, which is the probability at the end of the day, which is going to be 0.78. Okay, B part 2, find the value of P dash of T, the derivative of T, and explain what this means in the context of the question. So my P of T is equal to 0.3 plus 0.02 T. Differentiating that, or P dash of T, differentiating a constant is dropped, and then differentiating 0.02 T, that's to the power of 1, multiplying the power by the number in front of the T becomes 0.0 T. To the power of 0, and then anything to the power of 0 is dropped. So just 0.02. And what does this mean? This basically means, what does it mean? What do we say? Well, the probability that it's raining in the town is increasing at this rate basically per hour. So I have a constant rate of change there when I have it as a constant without a variable or a variable for T. So I'm just going to state the probability it rains in Waterville, the town, is increasing at a constant rate of 0.02 as a probability, as a percentage, that's 2%, so multiplied by 100, 2% per hour. So that's what that basically means. Part 3. At a certain time, the probability that it is raining, according to the model, is 0.35. Work out the probability that it is raining exactly 1 hour later, according to this model. So let's come back up to the top here. My model for it raining is the probability of T equals 0.3 plus 0.02 T. So that's my model. Now it's telling us that the probability that it's raining is 0.35. So I'm going to sub in that. That's the probability. Now what we're looking for here basically is we're trying to solve for T. So if I solve for T here, so I'm going to move the 0.3 over or take it away from both sides. So 0.35 minus 0.3 is equal to 0.02 T, which is 0.05 is equal to 0.02 T. Dividing both sides by 0.02 to get T on its own, that's giving me 2.5. 2.5 equals T. Okay, so it's raining at the hour of 2.5. The question then wants us to work out the probability that it's raining exactly 1 hour later. So that's going to be how many hours? That's add on another hour. So that's T of being 3.5. And I need to check now what's the probability of that. So I'm going to get my formula again. The probability is going to be 0.3 plus 0.02t. I'm looking now for the probability of our 3.5. So I'm subbing in 3.5 for t. So that's giving 0.3 plus 0.02, sub in my 3.5. And that's giving me a probability of rain of 0.37. Okay, so basically what you had to do is you had to solve for t. That gets you 2.5 hours. It wants it to get the probability an hour later. So that's going to be add on an hour. So 3.5 hours later. And then sub that back into your formula. Now, sorry, just if you can see it here, that's a plus sign there, not a t, so plus 1 hour. Okay, that's question 7 done. So question 8, a rectangular garden 50 meters by 30 meters contains an irregularly shaped pond of length 18 meters, as shown. Part A, find the area of the whole garden, that is the total area of the rectangle. So the formula for the area of a rectangle is given by length by width. So that's going to be length 50 meters multiplied by 30 meters. So my area of the garden is 1,500 meters squared. B, the width of the pond is measured at intervals of 3 meters, starting at the right-hand edge of the pond. These measurements are given on the diagram correct to the nearest meter. Use the trapezoidal rule to estimate the area of the pond. So the trapezoidal rule is coming from our log tables and is given as area equals h over 2 plus and so on and so on and so on. So I'm just going to fill that in for my trapezoidal rule. Now my h is my interval, the gap between them. So that's 3 over 2 multiplied by my first height. Now my first is here in the corner. That has a height of 0. Then I'm going to add on the last height, which is my 2 meters. So plus 2 for the last one. Then the formula tells me to go plus 2 times all of the other intervals. The other intervals are the 10, the 14, the 12, the 10 and the 8. So I'm going 10 plus 14 plus 12 plus 10 plus 8. So that's all of the other intervals. When I work that out on my calculator then, I'm getting an area of 3 over 2. Add the 0 and the 2, you get 2 plus 2 times all of the others, which is twice 54. So A is equal to 3 over 2 times 2 plus 108, which is 3 over 2 times 110. So the area of the pond is 165 meters squared. This question continues now in the next page. So part C. Suggest a way by which the trapezoidal rule could be used with different measurements to get a potentially more accurate estimate. Well, if you come back up to the picture here, see the way the intervals are spaced at 3 meters. To make this more accurate, what you should do and could do is by including more intervals. So if we actually increased the number of intervals, so rather than going 3 meters apart, maybe reduce the spacings of the intervals to 1.5 or 2. So the more intervals you have, the more accurate the area will be. In other words, the smaller the distance between the intervals, so the h is what it's called. So if we reduce the value of the h, the more accurate. So I'm just going to say reduce the interval spacings. That is, i.e., reduce the value of h from the formula. D. Apart from the pond, the rest of the rectangular garden is covered in grass. The actual area of the pond is 172. All of the grass needs to be resown. The cost is €2.55. Work out the cost of resowing the garden. Okay, so we measured it from the first part to be 1,500 meters squared. We're now going to subtract the area of the pond, which is 172 meters. So that's telling me that my garden, everything in green here, so that's what I'm getting here, and I've reduced my pond, which is this one here, the 172. So that's getting me a lawn covering of 1,328 meters squared. I'm now going to multiply that by the cost per meter squared, which is €2.55, which is getting €3,386.40. Now just go back up to the question. It wants it to the nearest €10. So that's going to be 3,000 300 and not 86, it's going to be 90 because 86 is closer to 90. So €3,390 to reseed the lawn. Part E. Some materials were imported from England by the gardener for resowing the garden. The cost of the materials was £840. This included an import duty of 16.9%. Work out the cost of the materials before the imported duty was added. Okay, so the materials cost £840. This included, sorry, I'm in the wrong one there, sorry, €840. Now this included the stamp duty, so that accounts for 100%, that's the seeding, plus the stamp duty of 16.9%. So in total, the gardener is spending 116.9%, which is my €840. So it includes the import duty. I want the price before the duty was added on, so that's the original price, which is 100%. Now before getting to 100%, I'm going to go to 1%. Let's find out what 1% is. So to do that, I'm dividing by 116.9 because 116.9 divided by 116.9 is 1, and I have to do that to both sides. So 1% is, let me just get my calculator, 840 divided by 116.9, which is coming up as £7.1856. Now I want 100%, so I multiply both sides by 100 there. So multiplying that by 100 is getting me a cost before the duty of £718 and 56 pence, and it wants it to the nearest penny. That is to 2 decimal places. Yeah, so £718 and 56 pence. F. The gardener paid £840 in euro. The exchange rate is as following. He also paid a fee of 2.5% of the £840 as commission. Work out how much he paid in total in euros, correct to the nearest cent. Okay, so a bit of work in this one. So I have my exchange rate, €1 is equal to £0.8547. Let's turn that into the £1. So I want to figure out what £1 is worth in euros. So I'm dividing both sides by 0.8547 because that's dividing by itself will give you 1, so I have to do that to the left hand side as well. So when I divide that, I'm getting £1 is equivalent to 1 over 0.8547. Now you can turn that into a decimal if you want. It wants £840, so I need to multiply both sides by 840, which is giving me £840 equivalent to £982.80 as euro. Sorry, so €982.80, I should say. So we come over now again and we have to deal with, he also paid a fee of 2.5% on the 840 as commission. Now you could have added the 2.5% on at the start. I'm just going to add it on to the euro value. So I need to go €982.80 plus 2.5%. So to get it as a percentage, we divide by 100 and multiply by my 2.5%. And when I do that, I get €24.57 as commission. And the question works out how much he paid in total. So I need to add the price for the gardening materials plus the commission. And that's giving me a total cost of €1,007.37. Again, you can work out the 2.5% at the start or at the end. Okay, so looking at 9A, the diagram below shows the actual daily number of new cases of a disease from day T being 0 to day 25. It also shows the number of cases according to a mathematical model over this period. So the dots are representing the actual and the line represents the mathematical model. So from the diagram, estimate the number of actual new cases. So the actual again is the dots on day 12. So day 12, well, if this is 10, 11, 12, 13, 14, 15, so 12 is this one here in red. So bringing this across, it looks somewhere between the 1 and the 2000. So we'd be safe to go 1,500, I would say there. According to the model, which is the curve, there are 1,000 new cases on day 12. So you can see here, so the actual being the 1,500 and the model, which being the curve, is 1,000. Work out the percentage error in the model's value for day 12. Give your answer correct to the nearest percentage. Now, we've seen this earlier in the exam paper, the percentage error, and we used the formula difference over original. Or another word for original being the exact, the precise. So we have the difference, so 1,500 minus the 1,000, the model and the actual, divided by the original or the exact. Now the exact is the actual, so that's 1,500, the dots basically. And we're timesing that by 100 over 1, and that'll give us our percentage. And when we work that out, we get 500 over 1,500 multiplied by 100 over 1, which is giving me 33.3%. Now the question wants to the nearest percentage, so 33%. Scrolling on down now to part 3, show that it takes approximately 5 days for the daily number of cases to double according to the model. Again, the model is the line. So if you're looking at the diagram there, you can start anywhere. You can start on 0, 5, 10, 15, 20. Down around the 0s, 5s and 10s, they're fairly tight. They're fairly hard to read off the diagram. So it might be safer to maybe go up to the 15th day and start around there. Because we've taken that, it looks similar to day 12's actual. So it looks like about 1,500, doesn't it? So let's say on day 15, we have 1,500 cases. Reading off the graph there on day 20, it looks as though it's slightly above the 3,000. So ever so slightly above the 3,000 cases. So it wants us to prove that it's doubling. Well, you can see here that it is doubling, because if you take the 3,000 cases, divide that by the 1,500 cases. Now this isn't exact, I'm reading from a diagram here. That is twice the size, so therefore it is double. Again, you can pick any days. I just picked day 15 and 20. IV, hence estimate what value of t, the number of new cases, will first be at least 100,000 according to the model. Again, the model is the line, not the dots. So I'm going to start here at day 15, day 20, day 25, day 30, day and so on and so on and so on. I don't know how far I have to go up. Let's start with that. So day 15, going from part 3, I got 1,500. Going from my diagram, I got 3,000. Now, from there on up, well, actually, can I read 25? I can read day 25. It looks just above the 6,000, so I'm going to keep it at just 6,000. These could be 3,100, 6,200, but it looks about that. That's as far as my graph goes. From here on in, I'm assuming, going from part 3, that it doubles. So it's now going to double to 12,000. Again, that's me just multiplying by 2. Doubling it to day 35, which would be 24,000 cases. I now need to go to day 40. I'm trying to get to 100,000 basically. Doubling the 24 brings me to 48,000 cases. Doubling that then to day 45 brings me to 96,000 cases. So there I am. I'm sure then if I get into day 46, I don't need to double it to day 50, because then I'll be up on just shy of 200,000. So I'm assuming here that it is going to be roughly day 46. So the question says, estimate on what day. So look at, I'm sure the marking scheme is accepting day 46, day 47, day 48, roughly around there. It's not day 45 anyway, because day 45 is 96,000. Okay, so that is question 9A and all the associated parts. Scrolling down now to part B. The daily number of new cases of a different disease is given by this model. Fill in the table below to show the values of dt for the given times. Okay, so they've done d of 2, d of 6. Basically what you're doing here is you're filling in 0 for t to get the first box. So that's 2100 multiplied by 1.18, and it's to the power this time. So on your calculator, just make sure you're going to the power button. And I'll do a few of them out here. So that's getting me 2100 on my calculator. I'm just going to do out, so that would be filled in here. I'm going to fill in this one here. So d of 3 would be 2100 multiplied by 1.18 to the power of 3 on my calculator. And that's getting me 3,450. So I'm just going to fill in the rest of them here for you. It's done the same way on my calculator. D to the 4 would be 4071, and filling in 5 for t would be 4,804. Okay, so that's my table complete. Now I need to graph those values here on my diagram from time 0 to 6. Okay, so let's fill that in. So at time 0, it's 2100, so I have a dot around here. I then have 1 goes up to 2,478, so roughly 2,500, which would be there. Then I'm going up just shy of 3,000 for 3, which is here. Then I'm going, that's for 2, and so on and so on. And the final one, for day 6, or t being 6, it's 5,600, which is about here. Again, then you'll connect them with a freehand sketch. Now, mine's on the computer here, so it mightn't be too clear. Looks something like that. So that's your graph. Again, there'll be a little margin of error built into the marking schemes, but it should look something like that. Okay, and final part to this question is part 3. Measures are put in place to slow down the spread of the disease. From t being 14 days onwards, the number of new cases starts to decrease. For t greater than or equal to 14, the daily number of new cases can be modelled by this. On t being 14 days, there are 21,309 cases according to the model. Use this to work out the value of a. Give your answer in the form. So this is your significant figures here. Okay, so first of all, let's figure out how many cases there were on that day. So we know it's 21,000, but we have to solve for a. So let's fill that in. So k of 14 is equal to a multiplied by 0.83 to the power of 14. In my next line, we know the value of k of 14. It's the 21,309 cases. A multiplied by 0.834 can just be written as a 0.83 to the power of 14. I'm sticking them together. If I work out 0.83 to the power of 14, that's getting me 0.07364. To get a on its own, divide both sides by that decimal. So it's 21,309 divided by 0.07364. And that's getting me a value of a to be 289367.19. The question then wants it to be given in the form b multiplied by 10 to the power of n to 2 decimal points. So I'm starting here and I'm going back to b being between 1 and 10. So I need to go back 1, 2, 3, 4, 5 decimals. So that's going to be 2.89 because it wants it to 2 decimal points multiplied by 10 to the power of, and I can't remember how many jumps I did, 1, 2, 3, 4, 5, multiplied by 10 to the power of 5. And that's your answer to question 9 finished. Question 10a part 1, find the volume of the cylinder with diameter 18 millimeters and height 5 millimeters. Give your answer to the nearest millimeter cubed. Volume of a cylinder is given by the formula pi r squared h from our log tables. If the diameter is 18 millimeters, to get the radius, we divide it by 2 or cut it in half, so that's 9 millimeters. So filling in my formula for volume, it's going to be pi multiplied by radius, so 9 squared, and multiplied by height of 5. So that's getting you a volume of 1272.3 millimeters cubed for volume. It wants it to the nearest millimeter, 1272 millimeters cubed. Part 2, a metal ring could be made by removing a cylinder of diameter 14 mil and height 5 millimeters from the cylinder above. Work out the volume of metal in the ring. Okay, so we basically just need to get the volume of the cylinder that we cut away and then subtract it from the volume of the overall cylinder. So let's have a look now at our new volume. So volume of the whole is going to be still a cylinder, pi r squared h. So that's going to give us pi multiplied by radius squared. The height stays the same, but the radius is now, well, my diameter is 14. I need to half that. So my radius for my cutout section is 7. So that's getting me a volume of 769.69 millimeters cubed. That's what I'm drilling out. That's what I'm removing. So therefore, the overall volume from part 1 is 1272. I'm going to subtract the removed metal, 769.69. And when I remove it, it's getting me an overall volume of metal left in the ring of 502.31 millimeters cubed. Again, it wants it to the nearest millimeter, so that's 502 millimeters cubed. Many gold rings are made of a mixture of pure gold and other metals. One particular ring weighs 8 grams. It contains 3 grams of gold. Work out the percentage of the weight of the ring that is pure gold. Well, okay, so we've 3 grams of gold out of 8 grams of mixed metal. Times that by 100 over 1, and that'll give you your percentage. So it's basically 3/8 as a percentage. Turn that into a percentage, we get 37.5%. So not too bad on that front. Scrolling down now to be part 2 on the next page. Pink gold is made up of pure gold, copper and silver. The ratio of the weight of pure gold, copper to silver is given by 15 to 14 to 1. Work out the number of grams of pure gold in the pink gold ring that weighs 25 grams. Okay, so ratios here, we add the 3 of them together. So 15 is to 4 is to 1. That gets 20 parts in total. I'm just calling them parts here. If we divide our total grams of ring, that's 25 grams divided by 20 parts, which is 1.25 grams. So each individual part represents 1.25 grams. If we now look at what they're asking us to do, it's focusing in on gold. So gold is made up of 15 parts of my ratio. So I 1.25 grams multiplied by 15 parts, which is getting 18.75 grams of the pure gold. Part 3, rose gold is made up of 75% pure gold, 22.25 copper, 2.75 silver. Express the ratio of pure gold, copper to silver in the ratio A is to B is to C in the simplest form. And this is important here. It wants it where they are all natural numbers. Okay, so we want gold is to copper is to silver. So I'm just writing down, that's my A, B and C basically. My gold is 75%. My copper, 22.25%, and my silver is 2.75%. Let's turn them into decimals maybe first of all. So that's dividing by 100. So 0.75 is to 0.2225 is to 0.0275. Now, again, these have to be whole numbers. So what I'm going to do here is, well, actually, you can see it here. Hopefully you can see that these are split into quarters. So 0.25, 0.75. So what we could do there is basically multiply across by 4 to turn those quarters into whole numbers. Now, what I'll also have to do is, maybe I shouldn't have actually divided by the 100, because I now want to turn them back into the whole numbers. So rather than just multiplying across by 4, I'm going to multiply across by 400. So maybe I shouldn't have divided by the 100. But anyway, let's do it. So multiplying across by 400 gets me 300 is to 89 is to 11. Okay, so we didn't actually have to maybe divide across by the 4 in the first place. Sorry, I shouldn't say that. Divide across by the 100 in the first place. We could have just multiplied this line here by 4. But look, it's what you see on the day. That is B part 3 finished on question 10. Scrolling down now to part C. So the cost of insuring a piece of jewelry depends on its value. The table below shows the rates. Okay, so I'll let you read that yourself. Work out the cost per year of insuring a ring valued at 1,800. So first of all, the first 1,000 is at 1% of the value, so we have to deal with that. So 1,000 at 1%, so divide by 100 multiplied by 1, that's getting 10 euro. The remainder of the 1,800 euro, which is going to be 800 euro, is at 2%. So see here, the next amount of money is at 2%. So that's 800 at 2%. So divide by 100 multiplied by 2 is 16 euro. So add those two figures together. 10 euro plus 16 euro is giving me a cost of insuring of 26 euro. The cost of insuring a particular necklace is 142 euro and 80 cent per year. Work out the cost of the necklace. Okay, so we need to kind of use our information from part 1 here as well. So remember that the first 1,000 euro that you insure is at the 1%, and that was a tenner. Okay, so that's definitely going to be in the price. So if you think about it, we have 142 euro 80 cent is what it's insured for. Take off the first tenner, we still have 132 euro and 80 cent to account for. So if we actually come back up to this section here, so we have the next 9,000 is at 2%. So let's assume we don't know what that amount of money is. Let's call it an X. So some amount of money at 2% is accounting for the 132 euro and 80 cent. We know that that's the case because if you go back, we know that it's within that 9,000 euro, because if you find 2% of 9,000 euro, you will get 180 euro. So we're not gone over the 180 euro at the 132. So we're okay. We're still, that's why I'm calling it X. So we don't need to look at the next percentage. So turning 2% into a decimal, that would be 0.02 at X amount of money. So multiplied by X if you want. So stick them together. So that's what we get, 132 euro and 80 cent. So to get the value, before we counted for the 2%, we divide both sides by 0.02, which is giving me 6,640 euro. So I had to spend 6,640 euro, insure that at 2%, which cost me 132 euro and 80 cent. So therefore, the original price of the ring, or the necklace, I should say, was the original 1,000 euro from here, and then the 6,640 euro, which ensures the price of my necklace would have been 7,640 euro. And I insured it for 142 euro and 80 cent. Question C, part 3. A brooch is valued at 17,500. The cost per year of insuring the brooch is 435. Work out the rate of the insurance charged on the amount of the value of the brooch, which is in excess of 10,000 euro. Okay, so I'm just going to scroll back to the table here just to explain that. So in excess of 10,000 euros. So the first 10,000 we've accounted for here. But anything over 10,000 in excess or above is at this new rate. And that's what we have to calculate. So let's work out each of these individually. So the first 1,000 euro is at 1%. And we have that done twice now, which is 10 euro from part 1 and part 2. The next 9,000 euro is at 2%. So divide by 100 multiplied by 2 is getting 180 euro. We then have the remainder of the brooch cost. So if we take away 17,500 minus the 1,000 and the 9,000, which means I still have to insure 7,500. So the remaining 7,500 is at some new percentage. I don't know what it is. That's what I have to calculate. But we know what it's worth. If you take this figure, the cost of insuring the brooch is €435. I'm going to subtract the two figures that I've already accounted for. So I'm going to subtract the €10 and the €180. So that means that the OR percentage accounts for €245. So I'm going to bring that in here now. So this €245 is some percentage of €750. So that means 7,500 multiplied by OR percent gets me €245. It's multiply, so to get rid of the multiply I divide. So that means that OR percent is equal to 245 divided by 7,500. So my percentage is going to be 245 divided by 7,500, which is coming up as 0.0326 with a dot, and it wants it as a percentage, so I'm going to times that by 100, which is giving me 3.26 reoccurring decimal, and it wants it to one decimal, so therefore it's going to be 3.3